Okay, today we're going to discuss conversions made easy, part 1. And we're going to take the decimal number 137. I'll write it out, 137. This is base 10, so what we're going to do is write in parentheses 10. This is 137. So what we want to do first is we want to turn this into a binary number. So what I do is I write out 1, 2, 4, 8, 16, 32, 64, and 128. So we know that 128 is just shy of 137, so we're going to put a 1 there. Okay? And though we know that if we add 128 and 164, that's going to go way over 137, so we're going to put a 0 here. Again, if we were to add 128 and 132, that would put us way over 137 again, so we're going to put a 0 here. So let's we're getting closer to 137, so let's add. This is what I do. Some people subtract. What I like to do, just from a personal standpoint, is add. So we'll put in 128 plus 16. That gives us 144. Once again, 144 is larger than 137, so we'll put a 0 there. Now let's try 128 plus 8. That gives us 136. We are just one shy of 137. We're going to put a 1 here. That gives us 136. So we know all we have to do is add one more. So 4 will be too high, 2 will be too high, but 1 will be right on the button. This number here is a binary equivalent of 137. So we're going to put in parentheses a 2 here because we know that is base 2, binary. So now what we want to do is convert to octal. We simply take the binary number, which is 1, 0, 0, 0, 1, 0, 0, 1. And all we do is break it down in threes. We go 1, 2, 3, draw a line, 1, 2, 3, draw a line. Okay, and at this point what I do is I write out 1, 2, 4, 1, 2, 4, 1, 2, 4. Okay, so we notice that there is a 1 here, so we're going to count this number. We ignore these because these are zeros. The next one we write another 1 here because there's a number there. We ignore these because they're zeros. There's a 0 here, we ignore that. There is a number here, so we'll put 2 here. We know that is 0. So the octal equivalent to base 10, 137 is going to be 211, and we'll put 8 there in parentheses to indicate that is octal. So the next step is we want to convert to hexadecimal. We take that same binary number, write it out again. It'll be 1, 0, 0, 0, 1, 0, 0, 1. This time what we're going to do is we're going to count up to 4 spots. 1, 2, 3, 4. Draw a line. 1, 2, 3, 4. Draw a line. This time we'll write out 1, 2, 4, 8. 1, 2, 4, 8. And we do the same thing. We have a number here, so we're going to put 1 here. Actually what we do, we're going to add 1 and we're going to add 8 because these are, they have a number here. So this will be actually 1 and 8 will be 9. Here we have a number here, so we're going to write out 8. So the hexadecimal equivalent will be 89, and we're going to write out 16 for the base. Okay, now what we want to do is write out the binary code decimal, and it's just like it sounds, binary code decimal. We're going to take the base of 137, which is a decimal, 137. And what we're going to do is we're going to break each digit down, just like this, and treat each one of these as individuals. So 137, we're going to write out 1, 2, 4, 8. Here we're going to write 1, 2, 4, 8. Here 1, 2, 4, 8. So what numbers do we add up to get to 7? Well, we'd write out 0 because 8 is bigger than 7, but if we add 4, 2, and 1, that will be 7. So we go 1, 1, 1. For 3, 8 is too large, 4 is too large. But if we add 1 and 2, we get 3. So we're at 1, 1. Here simply will be 1. Okay, and these will be zeros. So the binary code decimal for 137, if you break down each digit, and you write out 1248, 1248, 1248, and then you just write down the binary number for 7, binary number for 3, and binary number for 1, you get these 3 binary numbers. And this will be the BCD. This equals the BCD. And really it is, I struggled with this one day, kind of banged my head against the wall, took a break, looked at it the next day, and the light turned on, and it really was a lot easier the next day. So this is the way I do it, and I think this is the way that Ms. Brockett teaches, and in my opinion, it's the right way.